Now, same example. This time we have the definition, we have the hypothesis. I'm going to tell you, let's say the experiment gave us B hat. B hat is the sample proportion. If you go back and look at our notation, anytime we get an estimator, we put a hat. So it's not B anymore, rather B hat. Is B hat bigger than 0.7? Yes. Can I jump to conclusion and say that it is effective? No. We want to see if it is statistically significant. So B hat is 0.89. I'm giving you this. When we get to the test, I'll show you how to compute this value. So if P hat is 0.89, the corresponding sample Z score happens to be 1.82. So I did the experiments and it gave me 0.89. I would like to determine if it is statistically significant. So to get to that point, I converted P hat to a sample Z score. That value is 1.82. I picked a level of significance, 0.05. And where should 1.82 lie on this slide? Will it be here? Yes or no? No. How about there? No. Right here? No. No. So the sample Z score is 1.82. Did it exceed 1.645?
Yes. Yes.
Yes. So since the sample Z score is bigger than the cutoff, we are going to reject the null. If I rejected the null, then I am going to go with the alternative. Correct? I'm rejecting the statement. This goes away. I'm going to use that statement. I can say P is bigger than 0.7. H1 is the alternative. We rejected the null, so we go with the alternative. P greater than 0.7. Good. Great. But when you explain this to someone, or write it in an article or an editorial, or even explain it to your friend after reading an article or editorial, using all those fancy terms will be confusing. Yes, unless the other person is fully knowledgeable about statistics. But you know statistics to a certain degree. You read an article about this anxiety drug, and you're going to explain this to another person. How would you put it in words? So that is the inferential part. Inference is just a fancy word for interpretation. We want to infer what this means. How will we want it? I'll write it and then I'll explain. A simple statement, that's all I'm going to say. When we go for other cases, t-tests, two-sample tests, and all that, can you see? Do you want me to read it? Based on the experiment, using a 0.05 significance level, the anxiety drug is found to be effective. But here it says p-hat is 0.9. So a simple statement, does it explain the purpose of the experiment and its conclusion? Is this the only way to convey this information? If you write it, would you use the exact same words? No, you probably might write it in a different way. Perfectly fine. But you've got to specify you did an experiment, got to specify what level you use, got to specify the conclusion, have to specify the statistic, and I'll tell you why. You needn't explain this to your friend, unless your friend is being very particular and nags for more information. Then you can explain this. You know what this means, your peers know what that means. You're giving the conclusion, and this bit is important because one might wonder, well, what percent of people from the experiment found it to be effective, right? That number tells you 89%. Good. When I do the test, we will probably put a few more additional sample statistics, such as the sample size over here, so that people know how many participants were there in the study, and that was the percent out of the number of participants in the study who found the drug to be effective. Good. Simple statement, and that explains it all. So we do all that work to include this. Good. Very key. That is the objective.